We will derive single phase AC circuit consisting of pure resistance with the inductance and resistance with the capacitance are in series circuit. That means if you connect RL are in series or RC in series across AC supply, how exactly that RL circuit behaves and how the power will be absorbed and how voltage and current will phasor difference will occur. That we are going to discuss now. So if you see RL circuit, for example, I can say choke coil. Choke coil for the tube lights and CFL lamps is for to limiting the fast moving electrons and also fast moving charges, right? And also to energizing purpose for the two terminals of the CFL. So that purpose also we want a choke coil because we want more voltage at the time of starting, but current should be limitless. So single phase circuits, RL circuit and RC circuit. Let's see the circuit diagram. Okay. So this is a circuit consisting of resistance and inductance are series with the circuit across supply. That voltage V is equal to Vm sin omega t. Due to voltage, current will flow through the circuit. Voltage drop across resistance is VR. VR is equal to I into R. VL is equal to I into XL. If it is RL circuit, what about the voltage? Voltage remains constant because same voltage is flowing through the circuit. Either it may be a resistance, inductance, capacitance, any other one. Because AC supply is constant, in our home also we are getting RMS value 230 volts plus or minus 5% of tolerance. Similarly, here also we are having inductance. Best example is a tube light. Okay, choke. This is a choke coil. Voltage drop across inductors VR, so current and voltage are in phase with each other, and voltage drop across inductance VL I into XL. Current and voltage are in voltage across the inductor is like current and voltage lag behind the phase difference is 90 degree for inductance. That is VL. VL is equal to I into XL. Right. Supply voltage is equal to V is equal to Vm sin omega t. Right. So according to this, I'll just draw the vector diagram for this one. See here. This is for resistance. Okay. This is for I'll change the this one. This is for resistance. V and I are in phase with each other. For this one, inductance, current lags by voltage. This is VL, angle 90 degree. So this is total voltage. This one is VR. This one is VL. So what about the V? According to Pythagoras theorem, V is equal to root of VR square plus VL square. So VR is equal to I into R, VL is equal to I into XL, V is equal to root of I R square plus I into XL square. So V is equal to I into Z, we got the equation wherever the impedance is Z is equal to R root of R square plus XL square. The impedance in a AC circuits is similar to the resistance in a DC circuits. Like the unit of impedance is ohms. So what is impedance? Impedance which avoids AC current. I mean impeded or avoiding the AC current in the circuit. Right, that is called as a impedance. This is RL circuit. Okay, so power consumption will get power is equal to VI cos phi. Everything is same. Phi is equal to unknown angle. Right, power is equal to VI cos phi. So V is equal to M sin omega t. I is equal to Im sin omega t minus phi. Okay, plus phi is for in capacitance. So average power like power is equal to Vi, V is equal to Vm sin omega t, I is equal to Im sin omega t minus phi. So after taking this one integration, average power 1 by 2 pi 0 to 2 pi Vm Im cos pi by 2 minus Vm by cos by 2 omega t minus phi. This part becomes 0 after integrating. Okay, only we will get this part. Okay, 2 pi will get cancelled. If it is upper limit minus lower limit, we will get only power is equal to Vi cos phi for RL circuit. Okay. And what about RC circuit? RC circuit is the same. Voltage across the resistance is VR, voltage across the capacitance is VC, and supply voltage is V. So V is equal to root of VR square plus Vy square. So for the capacitance circuit, so what happens? The circuit diagram and vector diagram would be like this. Okay, like this. So this is total voltage. This one is VR. This one is VL. So if you want this voltage, V is equal to root of VR square plus VL square, right? So finally we'll get average power is equal to VI cos phi, because phi we don't know, this angle we don't know, phi. Okay, so that is RL circuit, and waveform also we can draw. Small amount of power will be there, power loss will be there in the resistance, and a large amount of the power flowing to the supply to the capacitor is more. So for that, so RC circuit we are using. Okay, so current flowing to this one I. So finally we got see the equations becomes 1 minute. Okay, so V is equal to root of VR square plus VC square. Finally VR is equal to IR, and VC is equal to IC. V is equal to root of IR square plus X square. V is equal to I into R square plus X square. V is equal to I into Z, where impedance is equal to Z is equal to root of R square plus X square, phase angle. So average power is equal to VI cos phi, power is equal to I into Z, I into R by Z. So power is equal to I square R. And the power in RC series circuit consumed only in the resistance, not in the capacitance. I told you, right, capacitance does not consume any power. Only resistance consumes power. There is a loss in resistance, I square R losses. It will get heats up. But capacitance, it will not consume any power, and inductance also it will not consume any power. So phi is equal to tan inverse of VC by VR. If you want to calculate phi, tan inverse of IXC by IR, so phi is equal to tan inverse of XC by R. So phi is equal to tan inverse of 1 by omega CR. Right. This is the capacitance circuit. Okay. So if you want to calculate phase angle by using the formula, we can use phase angle formula. Okay, this phase angle formula. And if you want to draw vector diagram as well as waveform for this RL and RC, I'll draw once for your reference. Here for RC circuit I'll draw. This is X axis, this one is Y axis. X is this one is Y axis. Okay, this is omega t. Okay, so I'll just voltage is constant for both. Like RC circuit, RL circuit, RLC circuit, voltage is same. So what about capacitance? Capacitance, small phase angle will be there here. So current leads by voltage at an angle phi, right? So small phase angle. What about the power? Power is here positive, negative power, small amount of power. So large amount of power is here, small amount of power. Sorry, here plus minus. You'll get, see here, both are plus. Power is here, both are plus, and this one is positive and negative will be there. So both are plus, you will get plus power is here. Okay, plus power is here, negative power is here. Here small amount of power, again negative amount of power is more, right? So don't confuse. Once again I'll draw for your reference. Okay, see here y axis, x axis, omega t. So I'll just draw voltage. Okay, this is voltage, and current is like this. Okay, so what about the power? Both are positive power, small amount of power. Positive power, positive voltage, negative current, so large amount of current. So this one is again small amount of current, small amount of power, again. So here this power is not equal to this power, so we got power is equal to VI cos phi. Okay, VI cos phi, right? This is the power, voltage, current waveform, right? Thank you.